Hello wonderful person, this is Anton, and in today's video we're going to be answering a simple question. So what other objects in our solar system have the magnetic field that is absolutely necessary for our survival? This is going to be a multi-part video where we're going to be talking about magnetosphere and various properties of it. So let's start with exploring our solar system. Welcome to What the Math. So first and foremost, magnetosphere. This is an absolutely essential property of a planet that is absolutely necessary for the survival of our species, because not only does it protect us from the super dangerous, highly energetic particles coming from the sun, but it also protects our atmosphere, it protects the water on our planet, and does a lot of really good things as well. The actual magnetosphere on our planet is thought to be made by the circulating of the very large liquid iron core on the inside here. So basically, because our planet is spinning, the liquid iron inside is also spinning, and since it's sort of has magnetic properties, as it spins, it creates this essentially magnetic loop around our planet that then generates the magnetosphere. This is sort of this is what we think is happening on the inside, although magnetosphere is still kind of a mystery to us because we don't really know enough about it. But we know it's important, and we know it protects our planet. And we know that both Mars and Venus lost a lot of their water and a lot of their outer atmosphere because their magnetosphere was either too weak or basically did not exist at all at some point. But let's start with Mercury. Mercury is actually another object that has magnetosphere, and you can check that by clicking this button. It's very weak. It's about the 100th of a time of what it is on Earth, but it does protect whatever is left on the surface of Mercury and protects some of the thinner atmosphere that Mercury does have. One of the reasons we think Mercury has such a strong, or basically has a magnetosphere, even though it's so small compared to other planets like Venus and Mars, is because it has a very large iron core. And its iron core is very likely to liquid, and as it spins, it creates a bit of a magnetic field. But one of the reasons we think it's so weak compared to Earth is because Mercury doesn't spin fast enough. The motion of Mercury, the orbital motion of Mercury, rotational period that is about 58 days. If it was spinning faster, it would have a much stronger magnetic field as well, magnetosphere. But as it stands, it doesn't have that. We think it's because of the rotation, because it does have a lot of metal in the inside. Now, Venus. We know that Venus doesn't have the classical magnetosphere, but it has something else that I've mentioned in one of the previous videos that is based on the interaction with the highly charged particles from the sun. As they strike Venus's atmosphere, they create a very unusual ionic ionosphere that basically surrounds the upper part of Venus and protects the lower atmosphere from being eroded. It's not a classical magnetosphere because Venus doesn't actually have that, despite having very similar properties and very likely very similar core to our planet Earth, because its density is also very similar. But we think that Venus doesn't have magnetosphere for two reasons. Either because its core may have actually solidified, although more likely, and this is actually what most scientists think today, it's because it spins so slow. Its rotation is 243 days. It's actually longer than 1 year on Venus. So because it spins so slow, there's nothing on the insides moving around, so most of the liquid core is very likely just kind of sitting there, not moving, not creating any field. And one of the reasons, or I guess the main reason why Venus spins so slow is because of its really thick atmosphere. Its really thick atmosphere over time slowed down Venus to the point of crawl. And this is something that we need to watch out on our planet Earth. If our atmosphere becomes too thick, we might actually end up slowing down with time as well. Let's go to Mars. Now, Mars is one planet that we're super interested in, but the biggest problem is that there's nothing to protect us here from the solar radiation. There's no magnetosphere whatsoever. Although there's something on it that I'm going to talk about in one of the next videos that does create a bit of a very unusual magnetic field around it. But nothing here to create magnetosphere, mostly very likely because it's just too small, doesn't have enough metal on the inside, and its core very likely has solidified and doesn't have anything moving on the inside to create any kind of magnetic field anymore. But with the exception of that magnetosphere that is kind of generated through a very unusual means, Mars is, for the most part, basically lacks one. So it's not very good for us if we ever want to settle there. Let's go to the next object that does have very, very strong magnetosphere. And you may have guessed, it is Jupiter. The magnetosphere of Jupiter is ridiculously strong. This is the strongest magnetosphere in our solar system, potentially even stronger than that of the Sun. Or not stronger, but at least larger. Now, it may not seem as large here if I enable it, but it is humongous. It extends all the way to Saturn. In other words, it's a very, very huge magnetosphere that is very likely created by the very fast rotation. 1 day on Jupiter is only about 9 hours long, 9.8 hours long. On the inside of Jupiter, inside of its thick atmosphere, there is something called liquid metallic hydrogen. This is hydrogen that essentially starts acting like a metal. And as it spins really fast around the planet, it generates a tremendously powerful field. This field is actually so strong that it obviously covers other moons of Jupiter as well. So every single moon of Jupiter is actually covered by this magnetic field, so it really kind of looks something like this in reality. And now, interestingly, in this particular system, there is another object that has its own magnetosphere, and this object is very surprising. It's actually the moon of Jupiter. It's Ganymede. Ganymede also has magnetosphere, not as large as Jupiter, but it's actually a magnetosphere within the magnetosphere. It's about 3 times more powerful than the magnetosphere on Mercury, and we don't really know what generates it. It's possibly because of the very highly conductive salty oceans underneath the surface, basically salt water that circulates under the ice of Ganymede and generates this magnetosphere, but this is just a guess at this point. It's very likely it's not iron core. And it's very likely that it would have been stronger if Ganymede spun or rotated a little bit faster than it currently does. But yeah, this is about 3 times more powerful than Mercury and very, very unusual. This is actually the only moon so far we've discovered that has its own magnetosphere, meaning that Ganymede might sometime in the future be one of the first locations where we build a colony. Now, similar to Jupiter, Saturn too has a magnetosphere and has exactly the same properties, although albeit a little bit less strong, and same generation or same way of generating this magnetic field. Basically, it is very likely to be the liquid metallic hydrogen underneath the upper layer of atmosphere that spins relatively fast. Here, the rotation is 10 hours instead of 9 hours on Jupiter. And this rotation, this fast rotation, and the fact that it's conductive metal generates this very powerful magnetic field here as well. Although, interestingly, the biggest moon of Saturn, Titan, seems to have nothing. It doesn't really have any field, and even though it's a very exciting object that has very thick atmosphere, it's kind of unknown what protects this atmosphere. Maybe it is the magnetosphere of Saturn, maybe it's something else. But yeah, it doesn't seem to have anything protecting it. Anyway, moving on to the next 2 objects that have magnetosphere, and the first here is, of course, Uranus. Now, Uranus also has magnetic field, but it's generated in a very unusual way. It's not liquid metallic hydrogen anymore, and what's even more interesting is that, although it doesn't really show in the game here, actual magnetic field tilts dramatically and doesn't actually align with the rotation axis. You can kind of tell that it's sort of on its own axis, and it spins very, very interestingly in a very unusual way. This also means that sometimes Uranus can have up to 4 different poles instead of 2 poles. So its magnetic field is very dynamic, very jumpy, and has a rotation axis of about 59 degrees here. So yeah, we don't really understand this completely, but we think that it's possibly generated by very large convection currents near the core somewhere, or also possibly by the electrical currents in the salty ocean underneath all of this within the planet. So because Uranus has quite a lot of water underneath, it's known as an ice giant instead of a gas giant. This salty water very likely spins really fast and generates quite a lot of magnetic field. And the rotation here is 17 hours. It's a little bit slower than Jupiter and Saturn, but enough for it to generate a relatively powerful magnetic field. And similarly, Neptune too has a very similar magnetosphere that generates in a very similar way to Uranus, with its axis being a little bit off the rotation plane. And so similar to Uranus, this magnetic field seems to interact a little bit closer to the surface of the planet, and also seems to be a little bit more dynamic, more unpredictable, and basically, if it was generated a little bit closer to the center of the planet, it would very likely go through the center. But here, the actual axis is a little bit off the center. This doesn't show in the game, but the reality is that for both Uranus and Neptune, the magnetic axis kind of lays somewhere over here and spins around the planet. Now, so that's basically the last object I was going to explore. Now let's enable all of the magnetic fields for all of the planets in our solar system, just so we can see what it all looks like. And so here we go, starting with Mercury. This is what it all looks like. Mercury has a very weak magnetic field. Then comes Earth, and it's very likely going to have a very small magnetic field in comparison to everything else as well. Then we have Jupiter with Ganymede on the inside that has its own magnetic field within the magnetic field. Saturn, Uranus, and Neptune. And these guys, as they orbit the Sun, will have these very, very large magnetic tails trailing behind them. And so essentially this is the face of different magnetospheres in our solar system, and this is how it's all going to look like, except for maybe Jupiter's is a little bit too large. It's more like this. And this is a very important feature, so we're going to make this a multi-part video and talk about the importance of magnetosphere in exoplanets as well, and why it's actually going to affect us in near future, and why we need to be developing technologies for how to create magnetosphere on various objects in solar system. Anyway, if you've enjoyed this video, don't forget to subscribe. Don't forget to share this video with someone who enjoys learning science and space sciences through video games. And consider supporting this channel on Patreon as well. Also, come back tomorrow because there's going to be something else related to sciences, and you're going to learn something completely different. I'll see you guys tomorrow. Let's go to Earth, take a look at it, and maybe, just maybe, see if we can kind of destroy it again. Because why not? I'll see you guys in the next video. Space out. And as always, bye-bye.